Hi viewers, this is Rajendra Kumar and I am a senior faculty for physics for IIT-G joint entrance examination. I teach both for mains and advanced. I started this video for the benefit of 11th and 12th students. At the same time, 8th, 9th, 10th, those who are seeking for foundation for IIT, for them also it will be helpful. Not only for IIT-G, these videos are also helpful for NEET students also. Today in my first video, I would like to present a small introduction on science and the first topic of physics, that is quantity. Now let us start rolling today's topic, that is science. What is science? It is derived from the Latin word scientia. It means to know anything. If you want to know anything, you should learn science. Anything, it doesn't mean that everything which is not practically proved. Science deals only the things which are practically proved and which we could able to prove, which we can try. Those things only it will deal. Now we will see its classification. Science is broadly classified into three main branches. They are physical science, biological science, and social science. What is the necessity for classification? In the ancient time, in the beginning, science was a small subject that one could able to learn entire subject. But as the time passed, it has grown to such an extent that one person couldn't be able to learn all the science. So that is why he is forced to classify the branches. Physical science deals with matter and energy. It is the study of matter and energy. Matter in all of its states and energy in all of its forms. Biological science deals with the living things. It is the study of living things. Social science, it is the study of society. What is society? The people, we, and the place where we live together is called society. So it is the study of society, so we can say social studies. And as these subjects are also further grown, they have classified even these into, for example, this physical science is classified into physics and chemistry. Biological science is classified into botany and zoology. And social studies classified into geography, history, civics, and economics. So in both physics and chemistry, we will study both matter and energy. In chemistry, it is atomic point of view, and in physics, as a bulk, we will deal physical properties and chemical properties, like that. But there is no demarcating line between the physics and chemistry as they are interlinked. Botany deals with the plants, zoology deals with the animals, and man also comes under this because man is also a social animal. And if we want to study the place, we should study the geography of that place. If you want to study the past of the people, you should study the history of the people. Similarly, civics deals with political organizations and economics deals with the economic related things. This is how we classified these. Now physics is further classified into number of branches like mechanics, thermal physics, electricity, optics, modern physics. These sub-branches will be dealt by the 11th and 12th students. Introductions of these will be given there. The basic knowledge which is required to enter into their graduation, that will be there in their syllabus. Not only this, acoustics deals with sound. Sound is a form of energy. Mechanics deals with the behavior of bodies under the action of force. What is force? It is the agent which changes or which tries to change the state of the body. For example, this is a thrust. It doesn't mean that no force is acting on it. Gravitational force is acting on it. Force exerted by the hand. If we consider wind force, that also acts on this. Even then, this is at rest, and we will say that this body is in equilibrium under the action of all these forces. So, in order to change its state, we need sufficient force to change its state. So, that's why we will define force as the agent which changes or which tries to change the state of the body. For example, if we apply force on the wall, it won't change its state. It doesn't mean that we are not applying force. We are applying force, but it is not sufficient to change its state. So that is why here the force is trying to change the state of the body. So that is why we will define force as the agent which changes or which tries to change the state of the body. And if a force is acting on the body, how it will behave? Either solid or liquid or gas. How it will behave? So that behavior will be learned in this sub-branch called mechanics. Thermal physics, study of heat. Heat is also a form of energy. Electricity, study of electric charges. Optics, study of light or study of electromagnetic waves, we will say. Modern physics. Physics developed before 1900 was named as classical physics, and the physics which developed after 1900 is named as modern physics. Further classifications also will be there, that when it comes, you will learn all the sub-branches in these. In order to explain the vastness of the subject, I will give you a small example, semiconductors. Small topic, we will think that it is a small topic. In lower classes, the children will learn less as their grades increases. As they goes to next higher levels, the subject increases. In graduation level, they will learn few chapters, and in post-graduation levels, they will learn, some books will be there to learn semiconductors. When the people goes to research, throughout their life, they can learn and they can do a research. So for this small topic only, a person can learn throughout his life he can learn. Just imagine how about the remaining physics. Not only physics, all the branches, they are vast. One cannot learn all the subject. So that is why how much is required for us, and basing on the time availability we will learn and we will leave. We shouldn't go to their extreme levels. Now with this small introduction, I'll start the first topic in physics, that is quantity. What is this quantity? Quantity, it is the answer to the question how much or how many. That answer is known as quantity. And the measurable quantities are known as physical quantity. So physics deals only with the physical quantities. And the immeasurable quantities like courage of a person cannot be measured. So such type of quantities will not be dealt in physics. Actually we should say physical quantity, but by short we will call it as simply quantity. Now the types of quantities. There are 5 types of quantities in physics. They are: first one is a ratio, second one is scalar quantities, third one is vector quantities, fourth one is tensor quantities, fifth one is phasor. What is this ratio? The quantities which have only numerical value, which doesn't have units, is called a ratio. In your lower classes you might have learned some ratios like relative density, specific gravity. Both are same. Relative density. What is this relative density? Density of substance by density of water at 4 degrees Celsius. As both are densities, their units gets cancelled and we will have only one numeric value will be there. For example, relative density of mercury is 13.6 and its density will be in Cgs the same, 13.6 gram per cc. So density in Cgs system and relative density are numerically equal. So these quantities which don't have units, which have only numbers, are called ratios. Refractive index is another example. Next, in physics there are some quantities which have both number and units. So both together is named as magnitude. So the quantities which have only magnitude means both numeric value and units, both together, is called a scalar quantity. To explain or to describe such type of quantities, the direction is not required. So that is why we define scalar quantities as the quantities which have only magnitude but no direction. For example, speed, distance. Distance we will say 5 meters. 5 is the numeric value, meter is the unit. So this is the magnitude of distance. While moving from a position to another position, for example, this is the path. This total length of this path is called distance. If the total length is 5 meters, we will say the distance traveled by the body is 5 meters. To describe this distance, direction is not required, because, for example, you are going in a car and here the direction of car is this. So we will say the direction of at this point, direction of distance at this point will be this. Similarly, at this point the direction will be like this. That means the direction of the car gives the direction at that point, direction of the journey at that point. So at every point the distances and the directions will be different. If it is going in straight line, the direction will be same, but if it won't go in a straight line, then the directions will be different at different points. So in order to describe the distance, direction is not required. So such type of quantity, similarly speed, 3 meter per second. This is numeric value, this is the unit of speed. So both together is called magnitude of speed. In order to describe this speed also, direction is not required. Direction is not required. So such type of quantities which have only magnitude but no direction are called scalar quantities, vector quantities. The quantities which have both magnitude and direction. There are certain quantities, in order to describe them, we need to mention their direction. So such type of quantities are known as vector quantities. It is not sufficient that it should have magnitude and direction, it also should satisfy vector laws that you will learn in that chapter. For example, here a body moves in this direction and the shortest distance is called displacement. While describing the distance, the direction is not required, but while describing the displacement from initial to final point, this is initial and this is final. For describing the displacement, it is required to mention the direction by showing an arrow. It gives that the body moved from this point to this point. That is initial to final. So to describe such type of quantities, we require both magnitude and direction, and such type of quantities are called vector quantities, like displacement, velocity, acceleration, momentum. Those you will learn in your further classes. Now here are some special quantities that I would like to explain. For example, time. Time is a scalar quantity. It doesn't mean that it doesn't have direction. It has its own direction, but it is unique. The direction of flow of time is past to present, present to future. So this is the direction of time, but this is unique. No need of mentioning its direction. So that is why it is not placed in vector quantity, it is treated as a scalar quantity. So the quantities which have unique directions will not be treated as vector quantities. And one more example is pressure. Pressure always acts downwards. So it is unique, no need of mentioning. So that is why even though it has the direction, we won't place it in vector quantities. It is a scalar quantity. Another example, angle. And the students of 11th and 12th standard do understand d theta. Very small angles will be represented with this d theta. D theta is a single term. D is separate, theta is not separate. Similarly, angles, finite angles, large angles will be indicated by theta. Now, this d theta is a vector quantity. Infinitesimally small angles are vector quantities and finite angles are scalar quantities. Finite angles are scalar quantities. So these two I will explain in the next video. So with this I am concluding my first video. I hope all of you like this. Those who like, those who want, please subscribe my channel, and if you have any comments, you please write down. I'll try my level best to present my future videos which will like by most of you people. Thank you very much for being with me.